Greetings. My name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 5 on integration and segment 5.6 on the fundamental theorem of calculus. In this segment, we will discuss a tool that's used to evaluate a definite integral, the fundamental theorem of calculus. I will refer to that as FTC. If f is a continuous function defined on a closed interval AB, and capital F of x is an antiderivative of the function f, then the definite integral from a to b of f of x dx is equal to f of b minus f of a. This expression is the definite integral of the function on the closed interval from a to b. A and b are called the limits of integration. A is the lower limit in this case, and b is the upper limit. And the difference, f of b minus f of a, can also be written with a vertical bar, f of x, evaluated from a to b. Let's work a problem. Evaluate the definite integral from negative 3 to 0, x squared minus 3x dx. We would begin by integrating the function. So the integral of x squared is x cubed divided by 3. The integral of minus 3x is minus 3 x squared divided by 2. This is to be evaluated from negative 3 to 0. So according to the fundamental theorem of calculus, we begin this evaluation by plugging the upper limit in first, 0. So if we substitute 0 for the x, we would have 0 to the third over 3 minus 3 times 0 squared over 2. When we work through this, of course, we would just have 0. Then we subtract from that the result of plugging the lower limit in. So let's plug the negative 3 into the function. That's negative 3 cubed over 3 minus 3 times negative 3 squared over 2. If you do this arithmetic, you would get negative 9 minus 27 halves, and continuing to simplify this expression, you end up with 45 halves, or 22.5. Let's work through another example, the integral from 1 to 3 of 1 over the square root of x dx. Again, we begin this problem by integrating, and since we have a radical, we first need to rewrite this expression. So I'm going to remove the square root, x to the 1/2, and bring it up to the numerator, x to the minus 1/2 dx. Okay, when you integrate x to the minus 1/2, you get x to the plus 1/2 divided by 1/2. And this is to be evaluated from 1 to 3. Well, let's simplify this and put it back in the radical form. The 1/2 would swing around and form a coefficient of 2, and then x to the 1/2 I'm going to put back as the square root of x. So 2 square root of x evaluated from 1 to 3. Again, we plug the upper limit in first, 2 square root of 3. Then you plug the lower limit in, 2 square root of 1, and you subtract those results. So in this case, we get 2 square root of 3 minus 2. If you go to your calculator, you can approximate this as 1.464, a decimal approximation. Either of these problems can be worked on the calculator, so let's switch to the calculator. And let's work number 1. I'll show you a calculator feature. Under the Math menu on the TI-83s, number 9, FNINT. So I'm going to select number 9. Okay, the parentheses was set up by the calculator. The first step is to type the function in. So our function was x squared minus 3x. We don't even have to integrate it. The calculator will do all that for us. Then insert a comma. The second step is to put the variable x in, followed by another comma. And then you put the lower limit of integration in, which is negative 3, followed by a comma, and then type in the upper limit of integration, which is a 0. Close the parentheses and press enter. 22.5, which agrees with the answer that we had. The disadvantage to this is you never see what you get when you integrate. The calculator started with the original function, integrated it, plugged the limits of integration in, and did all the evaluation, and all you see is the final result, 22.5. Well, that's it for this segment. Now you need to practice this concept by working similar problems. Good luck.